Hey everybody, sorry that I couldn't be there again today. Really hoping I can be back tomorrow, but it kind of depends on how things go today. So I thought I could at least make a video for you guys about how to do the different practice quizzes that I left for you. Please feel free to fast forward or pause or skip certain questions so you can just go to the questions that you need help with. I'm still planning on doing the test on Thursday and Friday, but hopefully this video will help you a lot with understanding any questions that you might be confused on. So let's start with number one. I think that generally you guys have felt most comfortable with getting common denominators. So I'm going to put a 1 underneath that 3. On the right side of the equation, I can tell that this side is going to need an x. And on the left side of the equation, the first one is going to need an x minus 4. And, sorry, it's a little hard to write on here. So, and then 3, of course, is going to need to have both. It's going to need to have an x and an x minus 4. That looks rough. Oh well. Okay. So now they have common denominators all the way across. So I'm going to actually need to multiply. So this is 10x minus 40 over x minus 4. And then I'm tempted to maybe kind of multiply this x times x minus 4. I just circled it. I'm going to kind of do it off to the side. That's x squared minus 4x. And then it has a 3 in front of it. So when I multiply that, I have 3x squared minus 12x over x times x minus 4. And then I'm going to multiply the right side of the equation. I have x squared plus 9x and x squared minus 4x. So, well, I could just leave that the same as the other ones if I wanted to. Okay, now they all have the same denominator, so I'm going to just work with the numerators. Sorry if you can hear Daniel Tiger in the background. Zeke is actually, I'm sick with a stomach bug, and Zeke is sick with maybe pneumonia. We have to go back to the doctor today, so it's been a little rough the past few days. So lots of Daniel Tiger in the background. All right, I'm going to combine like terms, and I know, and I'm going to kind of rearrange this. I know that I also am going to need to set this equal to 0 because I see I have a quadratic. So 10x squared minus 12x is negative 2x. And I just moved the 3x squared and the minus 40, so that way it would be in standard form. And then let's make this equal 0 by subtracting x squared. That's a 1x squared, so that's going to give me 2x squared. And then I need to subtract 9x. So I'm going to get negative 11x minus 40 equals 0. All right, now of course this one looks like it's going to be not so fun to factor, but that's okay. We need to try some things. So 2x squared is going to be split up into 2x and x. So this is the guess and check kind of way, or trial and error. I need two numbers that multiply to negative 40. I usually try to go with ones that are like close to each other, so maybe not like 2 and 20, but maybe more like 5 and 8. So let's try 8 and negative 5 and see what happens. So that gives me a positive 8x. This gives me negative 10x. Together that gives me negative 2x. That's not it. Okay, I'm tempted to try maybe positive 5 and negative 8 before I go too far. So that's 5x, and that's negative 16x. Hey, when I add those together, I get negative 11x. So there's my factors. 2x plus 5, and then x minus 8, and that equals 0. Remember, the whole point of this is I'm trying to solve it. So I'm going to set each of these equal to 0. And x equals 8. And x equals negative 5 halves, which is negative 2.5. Now, it was nice. Mr. Yosef was nice when he made this worksheet because he said check for extraneous solutions. So remember, we need to like take these numbers back up to the top, the very, very beginning, and make sure that with that white function up there, that I can plug in 8 and 2.5, 8 and negative 2.5, and they actually work. So I'm just using my calculator to plug the numbers in. I plugged 8 in on both sides, and I got 4.25 equals 4.25. When I plugged in negative 2.5, I got negative 1 equals negative 1. So both of my solutions worked. Okay. On to question number 2. Okay, Mr. Yosef gave some good tips on this question, some hints to help you out. The first thing he said was find the vertical asymptote. I also like finding the horizontal asymptote just for the sake of graphing. So because they have the same degree, I can tell the horizontal asymptote is going to be 3 because it's going to be the ratio. The vertical asymptote is going to be x equals negative 4 because that is what's going to cause the denominator to become 0. And then the next thing that he says is solve the problem. So we did a bunch of these in class last week where we basically just change this to an equal sign and actually just solve it. So let's solve it. I'm going to multiply x plus 4 on both sides so that way I can get rid of this. So I have 3x plus 1 equals x plus 4. And then when I solve, I'm just going to get the x's together and move the numbers over there. So I have 2x equals 3, and I get x equals 3 halves, or 1.5. Okay, so I know that kind of like my key numbers are going to be these. Mr. Yosta said to go ahead and make a number line. You can do that if you want to, but you don't have to. But I know that negative 4 is going to be like a key number, and then 1.5 is going to be a key number. And that's actually where they equal each other, so there's going to be like a filled in dot at 1.5. But we can actually, so now we can just look at the graph and see where actually is the rational function greater than or equal to 1. So I'm going to try to insert a picture of a graph here we can look at. All right, I just graphed this in Desmos, and what I did was I graphed the 3x plus 1 over x plus 4 first, and then I graphed y equals 1 second, so I graphed like each side of the equation separately, and now I have this picture. And so I'm looking for where the red is greater than or equal to the blue. That's what they gave me. So I can tell that it's going to be right here. I'm highlighting the yellow in the corner. That whole thing is greater than. And then it jumps to less than, and then it's greater than right here. Remember what our asymptote was. It was at negative 4. So I'm just going to put a little dotted line there so we can remember that. And then horizontal asymptote was at 3. So I am going to ask you guys to draw a graph by hand, but you kind of can just like sketch it. So you would graph those two asymptotes, and then you would graph the y equals 1 line, and just find a few points and then put the curves on there so I can see where it's true. So the areas where I've highlighted, that's where it's greater than. And I'm also going to ask you to be writing your solution in interval form, and then also like drawing it on a number line. So this part that I just circled, that is negative infinity to negative 4, and it's parentheses because it's not included. And then this part over here that I'm circling, that is 1.5 to infinity. And this time the 1.5 had a bracket because it is included, because it said or equals 2. So up here when I do my shading, if you look up at the number line now, I've got 1.5 to infinity, and I've got negative 4 to negative infinity. So kind of two pieces of my solution. There's the notation at the bottom, and then there's also the number line. All right, this is an example of one of those rate problems that you can do with an equation, or you can do it with a picture. I'll do it both ways. I think Mr. Yosef made this little table here to help you guys make an equation if you wanted to. Okay, so there's a project. We don't know what it is. I'm going to just draw a rectangle to represent the project. Mike takes twice as long as Rachel to complete a project. So that means if Mike does this much, then Rachel can do this much, because he takes 2 times as long to do it. Like, he's 2 times slower than she is. So she can do, another way to look at that is like she can do 2 times as much as he can. They can do it together in 10 hours. So Rachel can do this much in 10 hours, and Mike can do this much in 10 hours. So how long will it take each of them to complete it? So for Mike, it takes him 10 hours to do just this one little part. So if he wanted to finish the whole rest of it, that would be 2 more 10s, right? So it would take him 30 hours. But for Rachel, let's think about this. Am I erasing those 10s? She does those 2 blocks in 10 hours. So that means it would take her 5 hours to do this part and this part, which means it would take her 5 hours to do this part. So for Rachel, it's going to take her 15 hours. And that's totally acceptable to do on the test. If you just want to draw a picture, that's fine. If you want to make an equation, I think that this is a handy little chart here. So Mike takes twice as long as Rachel, so his time is going to be like 2R. Okay, I'm filling that in on the table. Rachel's time is going to be R. Together is 10 hours. So then the way Mr. Yosef kind of set it up here was like a rate, so project per hour. So Mike can do it in one project in 2 times R, and Rachel can do it in one project in R amount of time. And together they can do 1 project in 10 amount of time. So I'm going to write the equation down here. So 1 plus 2R plus 1 over R equals 1 over 10. And now this is a problem like what we've been dealing with, where we need to get common denominators and stuff. So it looks like we need to multiply this middle one by 2 over 2. And we need to, actually, let me back up. Not 2 over 2, because I forgot about the 10 over there. We should multiply the first one by 5 over 5. That way it'll become 10. The second one by 10 over 10, and the third one by R over R. And you can see I chose those things so that way I would have common denominators all the way across. So now I have 5 over 10R plus 10 over 10R equals R over 10R. And so I have 5 plus 10 equals R, because they all have the same denominator. So 15 equals Rachel's time. Hooray! And if Rachel's time is 15, and Mike takes twice as long, that means Mike would be 30. All right, so this is more like what the second standard is going to be like. The second standard is like a modeling standard. So we'll take that part of the test on Friday. But you are asked to graph this in your calculator, and then what's the horizontal asymptote and what does it represent in this scenario? So we do need to remember our horizontal asymptote rules. The big thing is that these actually have the same degree. Do y'all see what I'm circling in yellow at the top? And so because they have the same degree, you use the ratio of the coefficients, the leading coefficients. So it's going to be 92 over 1. So the horizontal asymptote is y equals 92. And I'm going to pull up a picture of this graph so we can talk about it. All right, here is a picture of the graph, and you would probably need to sketch this. And so I made my window, like basically I plugged a 1 in and I could tell that my y values needed to go up to like at least 600 and something. So I changed my y values to go to there, and then I just kind of zoomed until I could see the whole picture. But the question was about the the horizontal asymptote. So it looks like it's somewhere around here, which we know from what we just found that that's going to be at 92. So I think it would be helpful, always label your axes. So if you're asked to do a graph, like actually label what these are. So N was the number of years, and of course you can't type N in your calculator, so you would type it in as an X instead of an M. And then C was the annual cost. Annual cost. So it's how much the cost is going down per year over time, or just like how much the cost is for every year, what the annual cost is of the value of the refrigerator. So really, I don't know if cost is the right word. It might have been more like annual value would probably have been better. But since the horizontal asymptote is 92, the question is, what does that mean? It means that no matter how old the refrigerator is, it's going to at least have a value of $92 or about $92 because it's going to like kind of level out there. So that's what I'll put there at the top. All right, so you have to pardon my handwriting, but that says the least amount the refrigerator is worth, no matter how old. Find the average rate of change from year 10 to year 20. All right, when I see average rate of change, I'm really hoping you guys think slope. By this point, we've done a lot with that, and you need to remember how to find slope. So we need to find points. So these are two x values, so I need to know what the y value is. So 10 comma something, 22 comma something. So you could either use the graph trace in your calculator and type in 10 and type in 22, or you can just like take the actual equation and plug in 10 and plug in 22 and see what the y value is. When I plugged in 10 into the equation, I ended up getting 147. And then when I plugged in 22 into the equation, I ended up getting 117. So I need to find the slope between those two. So I'm going to have 117 minus 147 over 22 minus 10. Okay, so I plugged those into my calculator and found the slope. I got negative 2.5, and I will want the units here. So the units for y was dollars because that was the annual cost, and then the x was years. So this is going to be negative $2.5 per year. That's how much money or how much value it's losing each year from year 10 to year 22. If the domain is restricted from 1 to infinity, what is the range of the function? This is a really good question. So your range should always match your domain. So if you claim that your domain is 1 to infinity, then the range should match that as well. So the thing is, the lowest y value this is ever going to get to is 92. Because that was what my horizontal asymptote was when the function like kind of swoops down. It levels out at 92. So I need to plug 1 into the function and see what my new y value is going to be. So if you do 550 plus 92 times 1 over 1, that gives you 642. So your range would be 92 to 642 because those are the y values that go with those x values. The vertical asymptote of this function is 0 because there's an x in the denominator, and so if you plug a 0 in, that will give you a vertical asymptote. So that means that this function doesn't work at 0, like for 0 refrigerators, or for 0 years, it does not make sense. All right, so hopefully you found this video helpful. I'm sorry that it's so long. Again, feel free to use it if you want to, but you don't have to. I'm going to try to work through some of the next one, but I'm not sure that I'm going to have enough time to get it all together. So hopefully this video will be helpful enough to help you prepare for the test. And definitely feel free to see Mr. Yosef or Mr. Caldwell or the math tutors in the morning in Mr. Collins' room if you have any questions.